Hi, everybody. This is the first of a set of 3 mini lectures regarding climate change mitigation strategies, both technologies and economic processes. So up until now, we've been focused a lot on climate change adaptation, which is about what can we do to deal with the consequences of climate change as they happen. The highlight of this was the Marion sea level rise town hall meeting activity that you've been working on. What I want to start talking about now is what we can do to prevent climate change. And this is going to be the focus of your last assignment using the En-ROADS climate model. So as you may know, nations have made a variety of commitments to reduce greenhouse gases in the future. Some of them have gone back on those commitments, but many of them are sticking to them. And the question is, how technically will those commitments be met? It's easy to agree to something, but how do you actually achieve it? And we want to do so with the least harmful and most beneficial impact on our society and our economy. So where should we focus our efforts to try to get the most reduction in greenhouse gases at the least cost? And one final question is there a cost? Or can we solve the problem with technologies that save us money too? Is it possible to do good and also do well? That's going to be one of the focuses of the second of my mini lectures today. I want to start off by talking about how energy is used in the United States, what sources of fuel it comes from, and what purposes it's used for. And the core idea here is something called a Sankey diagram, which can be useful not just for this, but for a wide range of topics. Generally, the idea is it's a complicated web of interconnecting lines, and the width of the line is proportional to the amount of energy flowing from one place to another. So here's what we have for the United States as of 2019. It's a complicated diagram, but I'll walk you through it. On the left are various energy sources. You can see, hopefully, solar, nuclear, hydro, wind, geothermal, natural gas, coal, biomass, petroleum. All right. Those are used for a variety of processes on the right-hand side: residential in people's houses, commercial, businesses, industry, and transportation. And some of those processes do actually good, useful work. That's energy services on the back right. But there are some inefficiencies with using these fuels for literally anything. And so that's basically wasted energy, which is categorized as rejected energy. Often this can't be reduced. There's only so efficient that you can make an automobile engine or a power plant. There's laws of thermodynamics at play here. An important secondary box up at the top is the electricity generation box. So this is the process of converting raw fuel on the left into actual electricity, which is the orange band that goes into residential, commercial, and industrial on the right. Anyway, so if you take a quick look at this, hopefully you can get an idea for how the United States uses energy in 2019. Our primary fuel sources are petroleum, which we use to power transportation, automobiles, and natural gas, which is used for heating in buildings and generating electricity. One secondary player is coal, which is still being used to generate a significant amount of electrical power, but we're really not doing anything else with it to the most part. And then nuclear energy, which is entirely used for generating electricity. Other fuel sources or the sources of energy, solar, hydro, wind, and geothermal, are still very tiny and are really not quite insignificant, but a relatively minor player. We are still a fossil fuel powered economy. So, and I think that's an important thing to realize, and it's where I want to turn my attention to. You're seeing tons of solar panels on the people's houses, on the roadsides. You're seeing wind turbines cropping up all across the nation. And yet, even so, the impact of that on our sort of energy sector is relatively modest. There have been some big changes in the last 10 years. When I started teaching this class, the biggest thing that's changed is not that the renewables have gotten bigger. They have, but only a bit. The biggest change is when I first got hired in the early to mid 2000s, um, coal was number two, or actually maybe even number one, and natural gas was much smaller. We've seen a big, huge shift from away from coal and towards natural gas, and that's entirely due to the fracking boom. So we'll talk about that in a little bit. Um, Anyway, there's a lot of great details on this graph, and I hope you'll give it some time to take a look at in detail. So I want to focus a little bit on wind power and renewable energy, and some of the challenges that we face in the very obvious desire to replace coal power plants with a wind turbine. Anybody can look at the power plant on the left and say, that's big and ugly. And the thing on the right is sleek, elegant, and beautiful. It's in a cornfield, for God's sake. You'd probably prefer the one on the right to the one on the left, wouldn't you? Well, the devil's in the details. One of the details is that investments were made and loans were taken out to build the one on the left. And unless you're expecting, these things are typically replaced on a 30-year timescale. And there are huge extra costs in terms of abandoned capital expense if you shut one of these power plants down before it naturally dies of old age. But the more important factor is it's not a one-to-one comparison between the coal power plant on the left and the wind turbine on the right. Because the coal power plant on the left, which is the Brayton Point coal power plant in southern Massachusetts, provided 1,000 megawatts, which is about enough power to power 1 million households. On the other hand, the wind turbine on the right provides 3 megawatts, and only if the wind is blowing. So it's not replace a coal power plant with a wind turbine, it's replace a coal power plant with hundreds of wind turbines. While I think we can all appreciate that wind turbines are, better on a one-to-one scale, the physical impact of these across large amounts of landscape is potentially a significant issue. And the neighbors of wind turbines don't particularly like them. They're loud and noisy and distracting. And people tend to complain when you put them in their neighborhoods. And part of the challenge with wind and also solar is that it's spread out thinly. The available resource is spread out thinly across the planet rather than being concentrated in a single plant. And so as a result, their energy capture devices, solar panels, wind turbines, need to be in everybody's business. They need to be in backyards, in neighborhoods, and in middle of towns. Basically, you need to see them everywhere. The fact that you don't is part of the indication of how little impact they have had yet on America's energy infrastructure. In order for us to grow renewables, you're going to have to see them everywhere. And maybe that's okay, but. All right, the biggest currently operating offshore wind farm in the New England area, and one of the only ones in the United States, is the Block Island Wind Farm, which I had the good fortune to visit last summer. We went out in a boat. It was awesome. But this picture is better than any of the pictures I took. Generates about 30 megawatts in ideal conditions and 10 megawatts on average. That'll power all of Block Island plus a bit. But if we're going to power all of Massachusetts with offshore wind farms like this, we need 1,000 of these farms, stretching all up and down the coast, impacting tourist views, fishing, all that stuff. All right, and probably we should be, happy to do that, but we should be prepared for the impact that that's going to cause. All right, so power plants are changing. As I said, coal is being phased out. Another fun thing I did last year was I got to see the demolition of the Brayton Point power plant's cooling towers. This is a coal power plant. These are not nuclear reactor cooling towers. Um, anyway, environmental regulations, the cost of coal compared to other fuels, there's a whole bunch of reasons that this went out of business. Um, but if you're hoping that this old dirty coal power plant fell down and was replaced with new solar and wind power, that's not really the way it worked. In practice, um, the lion's share of the energy from this power plant is now being made up for by newly constructed natural gas power plants, whose growth in Massachusetts has vastly exceeded wind and solar. So I'll talk about that competition in a little bit, but I want to focus our attention now on reducing CO2 emissions and how we can go about doing that. Now, if you've paid any attention to anything over the years, you probably have a lot of good ideas, and many of these ideas are discussed in the news all the time: wind, solar, electric vehicles, yada, yada, yada. All right. There's a lot of these that are obvious and you already know about. So I'm going to skip those. And I'm going to talk a little bit more about some of the less obvious technologies and tools that we have for reducing CO2 emissions. Um, One of the more interesting ones is carbon capture and storage, which many of you have heard of. It's quite interesting. It comes with some significant risks. The idea is you keep burning natural gas and coal and you keep generating carbon dioxide just as you always have. But instead of releasing it into the atmosphere, you capture it in a pipe and you store that CO2 deep underground where it won't escape. So instead of entering into the atmosphere and causing climate change and entering the ocean and causing ocean acidification, it just goes back into the ground where it came from. Easy peasy. So this technique would use geological storage to store things in porous rocks underground. And the idea, you bury it more than a kilometer down, and the things are sealed up and it can't escape out into the atmosphere, right? And finally, another option, which is kind of interesting, is oil companies are interested in using this carbon dioxide to pump into oil and gas fields that are starting to lose their pressure, building up pressure in the reservoir and pushing more oil and gas out. So this means that we could actually use the exhaust from burning fossil fuels to generate more fossil fuels, and then take the exhaust from that and dump it back into the same oil wells and gas wells that it came from. So maybe that's interesting. I don't know. If you're appalled, I don't blame you. But the trick here is you got to make sure, very sure, that the CO2 doesn't get back out again. All right. You can't store it as a gas. You need to turn it into a liquid, and it's only a liquid at high pressure. So there's a lot of energy and work that needs to be done to compress that gas down into a liquid form. And where does that energy to do that come from? Well, you got to burn more fossil fuels. So you got to pick storage sites that are stable for centuries or thousands of years, or you've wasted everybody's time. And the cost of the infrastructure and the extra energy to compress the gas and pump it underground may double or triple the price of electricity compared to what would be done using ordinary fossil fuels. So on the one hand, this idea of still using fossil fuels, but now they're safe, is interesting. On the other hand, it's super expensive, and this technology probably costs more than wind and solar energy would. And so there's some big question about why would we even bother. Another factor that a lot of people don't think about is continuing to burn fossil fuels, but switching from one fossil fuel to a different one. And as I said, this is something that we're doing right now, not as a deliberate policy of climate change, but just due to the economics of fracking, have made natural gas much cheaper than coal. And so we can switch from coal to natural gas. And natural gas produces about 40% less CO2 than coal for a given amount of energy release. You produce a lot less CO2 with natural gas than coal. Not all fossil fuels are equal, all right? And so switching fuels can actually make a significant difference. It comes with all the exciting problems of fracking, which I'm sure you've heard about. But the environmental consequences of coal are no picnic either. So switching from one fuel to another may make a difference in the climate problem, but its local environmental effects are a completely different story that we need to talk about. In any case, this idea of switching fuels from coal to natural gas was actually at the heart of the Green Power Plan that was set up under the Obama administration and later made to disappear by the present administration. Um, the Obama plan is often talked about as promoting renewable energy, wind and solar, and it does a little bit, but the centerpiece of the plan is to restrict the CO2 intensity of fossil fuel power plants so that they must produce less CO2 per kilowatt than a given amount. On this graph, that amount turns out to be exactly the difference right in between coal and natural gas. So one way of thinking about what the Green Power Plan was it was really an effort to encourage the US to switch away from coal and towards natural gas, rather than specifically going for wind and solar. And that's maybe a cynical way of looking at it, and it's a moot point anyway at this point. Vote, kids. All right. So that's it for this section, and in our next thing, I'll start talking about economic measures that we can take to try to improve the way that we burn fossil fuels, and tools for making economics work for us rather than against us. Thanks for listening.